Good day. Today we're going to be doing the inverse of logarithms. So we have three logarithm problems here. Okay, we're going to be doing the inverse of these. And one of these is an exponential equation. Okay, the reason I included this exponential equation with these three logarithm equations is that it uses similar concepts. And before we get started, we are going to go over a few basic ideas or basic concepts and what you need to know before we get started. Alright, the first idea or concept that you need to know is how to convert between a logarithm equation to an exponential equation. So logarithm equation is going to kind of look like this. Log base b, okay, m equals n. Okay, and what that's saying is that you have some number here, b, raised to the nth power equals m. Okay, this is your base. Log base b, we say log base b of m equals n. What that means is here's your base, log base b. Okay, here's your base, raised to the nth power equals m. So an idea of what this would look like is you have log base 10, okay, of 100 equals 2. And what we're saying is that 10 raised to the second power equals 100. Okay, here's your base, base 10. Here's your base. Here's your exponent. So you have your base and your exponent. Okay, here's your base. Here's your exponent. Saying that equals 100. So this is kind of how to convert back and forth between your logarithm and your exponential equations. Okay, so if you have log 1000 equals 3, okay, if you don't see a number here, a base number here, see here we have this base 10. If you don't see anything here, okay, if it's left blank, what you're going to automatically assume is that that's base 10. Okay, base 10 is the only one. It's the only base where they don't always write it in. So if you see this, what it's saying is that 10 raised to the third power equals 1000. Okay, once again, if you don't see a number here, okay, a little index, you're going to automatically assume that that's base 10. So I'll go ahead and write that in red here for you. Okay, that's going to be base 10. Okay, also if you have something like log base 5 of 125, okay, equals 3. What that's saying is 5 cubed equals 125. Okay, you could have any number here as a base. You could have 2, 3, 4, 14, 212, any number that you want as a base number. Okay, and all it's saying is 5 raised to the third power equals 125. Okay, so this is kind of the first idea. This is what I would write down here, this key, log base b of m equals n. Okay, and this is what it means. Okay, so logarithms are kind of used. We use logarithms when we don't always know the base, or we don't always know this exponent. Okay, it's kind of telling us the exponent. So kind of like if you have your calculator and you have this logarithm here, that if you have, log base 6 of 216 equals what? Okay, so you know what it equals and you know the base. What you don't know, okay, that's saying that 6 raised to some number equals 216. Okay, so this is the reason for logarithms. If you don't know this exponent, okay, this is what you would punch into your calculator, log base 6 of 216. And then what it's going to do is it's going to spit you out the answer. And it's going to give you the exponent. So that's the kind of the purpose of these logarithms, is to, so you could solve for this exponent. This is the unknown. Okay, so the first concept, once again, is what I would write down is that you have log base b of some number m equals n. What that means is base b raised to the nth power equals m. Okay, this is what I would write down. Okay, kind of the second concept that you need to know is this. If you have log base b, okay, log base b of b to the n, that's going to equal n. Okay, and here's why. Okay, remember that if you have log base b, this is the exponent. See, log base b raised to the exponent equals m. So what you're saying is log base b raised to this exponent equals this number. And that's true. You can see b raised to the n equals b raised to the n. Okay, that's kind of like this. If I were to use numbers, it would be like if I have log base 10 of 10 squared equals 2. Okay, because that's true. Log base 10 of 100 equals 2. Okay, if I have log base 5 of 5 to the third power, that's going to equal 3. Okay, so this is the other concept that I would write down here, this one here. Log base b of b to the n is going to equal n. Okay, so these are kind of the two concepts to write down. And we'll be using these. We're going to go over these. Here's the first one. Here's the second one. Okay, we're going to use these in these problems that I have for you. All right, here's our first problem. Y equals log base 6 of 3x. So to do the inverse, remember we're inverting these. We're going to find the inverse. First thing you want to do is transpose the x and y. So what that looks like now is x equals log base 6 of 3y. Okay, kind of switching things around the equal sign. We have log base 6, 3y equals x. And you notice that this is similar to the first concept that we had here that I wrote out for you. Okay, here's our base, here's our base, here's our exponent. So what this is saying is that 6 raised to the x power equals 3y. Okay, just going off of our key. Alright, now solving for y, we're going to divide both sides by 3. So we have 6 raised to the x power over 3 equals y. And this is our answer. Okay, sometimes another way you'll see this is inverse of f of x. Okay, inverse equals 6 raised to the x over 3. Okay, and that's if you're starting off with f of x equals log base 6 of 3x. Okay, so sometimes you'll see the answer either way. You could either see it written as y equals all this or inverse of f of x equals all this. Okay, either way is fine. So you could write this as your answer, you could write this as your answer. It just depends on where you start. Okay, you can start with y equals all this, or if you start with f of x equals all this. All right, here's our second problem. We have y equals log base 2 x plus 6. Now this is different. If I had this, okay, log 2 x plus 6 is different than log 2 of x plus 6. Okay, that's different. If you notice these parentheses, okay, that's going to be something different than without them. So without them, what it's saying is that you have this, you kind of have this log base 2 of x, and then this plus 6 is tacked on as kind of an afterthought. Okay, so what we want to do is first thing we want to switch x and y. We want to transpose those. So now we have x equals log base 2 of y plus 6. Okay, first step when we're finding inverse is to switch out the x and the y. Okay, now solving kind of for y, what we're going to do is subtract 6 from both sides. So we have x minus 6 equals log base 2 of y. Okay, now another way to write this is if we kind of we could kind of put things on one side to the other. So we have this log base 2 of y equals x minus 6. Okay, and what that's saying, once again, from our little concept here, okay, is that this is saying that 2 raised to the x minus 6th power equals y. Okay, 2 raised to the x minus 6th power equals y. Okay, and that's our answer. Okay, this is the inverse. So we started here. This is the inverse. And once again, we're using this as our key to finding the answer. All right, here's our next problem. Y equals log base 2 of x cubed. Okay, first thing we want to do is we want to transpose x and y. So now we're going to have x equals log base 2 of y cubed. Okay, another thing you could do is kind of put these on one side or the other. So you could have log base 2 of y cubed equals x. Okay, that's simply putting one, kind of putting these across the equal sign, one side to the other. Okay, that's a perfectly fine maneuver you could do. So what this is saying here is that 2 raised to the x power equals y raised to the third power. Okay, simply, once again, we're just using our key. Okay, here it is. Here's our base 2. Okay, base 2, here's our n, we have x. So 2 raised to the x equals y cubed. That's just the exact same as this key that we've been using. Okay, base b. Here's base b raised to the n equals m. Okay, so now what do we do here? This is a good question. What do we do at this point? So we have 2 to the x equals y to the third power. Okay, what you could do to get rid of this cube, because you're trying to get y by itself. So to get rid of this cube, what you're going to do is raise both sides to the 1/3 power. Okay, and see what that does is it cancels out over here. So now we have 2 to the x raised to the 1/3 equals y. Okay, now when you have this, when you have something being raised to a power being raised to another power, okay, you multiply those together. So what we have now is we have 2x, 2 raised to the x times 1/3 equals y. Okay, that equals 2 raised to the x over 3 equals y. And there's our answer. 2 raised to the x over 3 equals y. Okay, simply going back to your algebra, when you have a power being raised to another power, okay, you multiply those together. And that's this point here. We have 2 raised to the x times 1/3. Okay, so here's our answer. We invert this logarithm, and this is what we get for the answer. All right, last problem here. We have this exponential problem. Okay, exponential problem. So we want to find the inverse of this. First thing we're going to do is transpose the x and y. So now we have x equals 5 raised to the 4y plus 1 all over 2. Okay, now what we want to do is we want to get this y by itself. So we're going to multiply both sides by 2. So now we have 2x equals 5 raised to the 4y plus 1. Okay, now at this point, what we're going to do is we're going to use this second concept that I had written down here for you. Okay, this log b of bn equals n. So how we're going to use that, maybe I could put this a little bit lower here to the side, is we're going to do it like this. It's going to be, okay, we're going to take the log of base 5 of both sides. Okay, so it's going to be like this. Log base 5 of 2x equals log base 5 of 5 raised to the 4y plus 1. Okay, see what that does, we just did a log base 5 on both sides. Whatever you do to one side, you have to do the other side. Okay, now what this does is you basically have this. Okay, log base b of b to the n equals n. Okay, kind of like if you have this log base b of some number b raised to the n, that this log base b and this b kind of cancel out. And all you're left with is n. So this and this are going to kind of cancel out. So what we're left with is we have this log base 5 of 2x equals 4y plus 1. Okay, this log 5 and this 5 kind of cancel out because of this rule here. Okay, I would write this down. This is kind of the second key, kind of a Important note. Okay, now just solving for y, we just need to get y by itself. So we're going to subtract 1 from both sides. So we have log base 5 of 2x minus 1 equals 4y. Okay, now just dividing both sides by 4. Cancels out. So what we have is y equals log base 5 2x minus 1 over 4. Okay, and here's our answer. Log base 5 of 2x minus 1 over 4. Alright, I want to thank you for making it to the end of this video. If you like it, please hit the like button, leave a comment down below, and subscribe to my channel for more videos. Thank you.